Welcome to day 2 of the OPC Day conferences. Now, for this talk, I am going to talk about how OPC UA can help connect your factory to the cloud. And the cloud, connecting to the cloud has become pretty much a mandatory requirement in fact any sort of factory automation system today. Now, we still have, and it's not going to go away, the networks of computers that are running on the factory floor that have to operate relatively independent of the cloud. But there's going to be this connectivity, this need to get data to and from applications that are running in the cloud, which include remote HMIs, ERPs, historians, or big data analytics engines. There's all sorts of different possibilities in terms of how these cloud applications work, but it's become an essential part of the environments that we have to build. And OPC UA has a number of features which can be adapted to allow you to connect your factory networks back to the cloud. Now, to understand how OPC UA can help, we need to start by talking about how the layered architecture of OPC UA, which cleanly separates out the application logic, the APIs, the information models, and all the stuff that you would be using to develop your applications from the actual mechanisms you get the data across the wire. And this includes the mechanisms for encoding the data, the mechanisms for securing the data, and the mechanisms for physically transporting it across the network. Now, this separation allows us to preserve the same application level and the same information models, which are a key element of UA, but be able to transport them in different ways depending on what your requirements are. And as soon as you start going outside the factory floor, you have some unique requirements created by the nature of the cloud applications that are out there, the restrictions that are placed on networks in terms of firewalls and accessibility that require that the simple binary TCP communication isn't a practical option. And that is where some of these alternate encodings and alternate transports can become quite useful. So the simplest example of how you can take advantage of these alternate transports to create something which is going to be much friendlier to work with cloud-based services are the concept of a sessionless service. A lot of the base UA services don't require anything resembling a session. You just do a read, you say, I want to get a value of this. They shouldn't need a session. And if you combine a read call with some mechanism for user authentication, such as OAuth 2, which is a standard authentication mechanism that's supported by all the major cloud vendors, and you combine this with a JSON encoding and an HTTP transport, you have something that looks a lot like a simple REST-like API, where you have an application that's posting a JSON document and getting back a JSON response. Now, the advantage of this is that now you could potentially build stripped down OPC applications running in the cloud that are basically websites that are serving up JSON, processing JSON documents. They're not because they're not intended to be complete UA servers. They're just providing some supplementary features which your factory needs to take advantage of. And you'd be going out using HTTPS and JSON, which generally will keep the IT department happy because they like to be able to do deep packet inspection, and they only open up HTTP and all these other restrictions. So So there's lots of different ways that this particular feature could be taken advantage of in order to connect you back to the cloud. Another situation that you run into is that because of these restrictive firewalls, you can't get to a server. You could have a server sitting behind a firewall, but there's no open ports. So what we've done is we've built into this protocol the concept of a reverse connect, which is basically the server calling out and saying, "Hey, I'm here. You can connect to me via this channel that I just created." And this capability can then be combined with a generic relay running in the cloud that would allow a client to connect to the server via the relay without actually requiring any holes to be poked into the firewall that the server is running behind, other than the outgoing port that allows it to connect to the relay. Now, because these relays, you need to have some security. You still need to have some sort of authentication to make sure that nobody's unauthorized connecting. It makes sense that this channel would be something like a WebSocket running over HTTPS that would connect to the proxy. And once you've got that WebSocket running, you would then exchange your binary messages as you would before. And the nice thing about OPC UA is because the messages themselves are encrypted, they can flow through this relay without the relay being able to see or modify it. So you've got complete end-to-end encryption, but also the ability to leverage this infrastructure to allow clients and servers that are distributed around the world to communicate with each other. Another aspect of UA, which will become important when it comes to building that connectivity back to the cloud, will be PubSub multicast. And this is a common scenario that you'll see with the cloud, where you have specific data that needs to be reported, but it needs to be delivered to multiple subscribers that may or may not be online at the same time. And the PubSub itself is well suited for basically packaging up these messages, securing them, and sending them out over some middleware that eventually gets delivered to the subscribers. And then there's a separate security key server, which allows authorized subscribers to get the keys that would be needed to decrypt and verify the messages. And this model can then be applied to standard broker technologies, which again are a key part of the cloud infrastructure out there that people may want to be able to use. And so now what happens is that you're doing the same thing that was shown in the earlier slide, but now what's happening is your subscribers are listening on a queue that's managed by a broker, and they're pulling the messages off as they come in. And you've got complete end-to-end security, so you don't care that the broker may be persisting sensitive data on its disk because it needs to store them somewhere, store that data temporarily at least until it's picked up by all the subscribers, because you've got this separate back channel that's used to distribute the keys that are needed to access that data. The last sort of little piece that we've built into the UA spec that I wanted to bring up is one of the unique characteristics about the cloud is you have a lot of existing infrastructure which is designed to handle all sorts of data, and it may be UA aware, but a lot of times it isn't. It's just it's basically designed saying, give me a bunch of XML data or give me a bunch of JSON data, and I will process it and I'll index it and I'll allow you to do all sorts of cool stuff, cool analytics with it. Now, with the JSON encoding, when we were using the encoding for UA app, a client to talk to a server, and we're using JSON to talk to send the messages back and forth. These messages have to have a lot of information in there that's necessary to completely replicate the original data that was sent. But if you have a scenario where you're simply publishing data to a generic analytics engine that just wants the JSON, you don't need to put a lot of this this additional data in there that's needed to replicate, to basically reverse the encoding mechanism. And that's why we developed this non-reversible encoding, which allows you to create JSON documents by following a standard set of serialization rules that look much nicer and are much more well suited for indexing by these generic cloud-based analytics engines. So I've gone over a few different sort of building blocks or Lego blocks, or however you want to imagine that you can use to connect that UA has to allow you to connect your factories back to the factory floor. But the reason why you want to do this is because by keeping UA in the loop and not sort of saying, oh, we're just going to go up to the edge and then we're going to do some proprietary protocol from there, you preserve the information model that will flow seamlessly from your controller up to the cloud. And as you'll hear from the talks that will follow me, talking about some of the stuff that Microsoft is doing with Azure, right to the point where you can have device twins in the cloud that look and act like the device, and that's all because they're replicating the information model. And that's why you want to be using UA to push your data up to the cloud, as opposed to some bespoke alternative that's designed just to collect the data and push it up. That's about all I have to say on this topic. Thank you very much for listening to your time.